learned how to find some trig values for some special angles. Yesterday we talked about our axis angles. So those are the ones that when we graph them, they land right on one of those x or y axis lines. So they're the multiples of 90. So 0, 90, 180, 270. So we learned that we use our unit circle to do those. And that the point gives us the cosine and then the sine alphabetically. The first part's the cosine, second part's the sine. And then that tangent is sine over cosine. Today, our angles are axis lines. They're going to land somewhere kind of in the middle of the quadrants. But they are going to be special angles for us. So our steps. First step, we're going to draw the angle. So we learned how to graph angles back a couple lessons ago. So we're going to begin by graphing the angle. Then we are going to connect to the x-axis. Always the x-axis. So we are always going to be drawing an angle to connect to that x-axis. I really can't emphasize this enough because I always think that I'm overemphasizing it, and then as students get going on homework, they start connecting to the y-axis. So I really cannot overemphasize this apparently. You always, always, always need to make sure you are connecting your angle to the x-axis. Then we're going to find our reference angle. Yesterday we talked about that acute angle that connects to the x-axis. So when we close in, we should be closing in that reference angle. That reference angle must be 30, 60, or 45. Those are the only options on these types of questions. The reason why it has to be one of those three is because those numbers are special triangle numbers. So once we figure out what that reference angle is, we're going to label in the sides of those special triangles. So yesterday I reminded you of what those patterns were and said it would be really helpful if you were comfortable with those patterns here. Then we're going to use SOHCAHTOA to find the particular trig function that we're asked for. So first step, draw the angle. So we're going to begin by drawing negative 210. So I begin at my 0 line. Negative tells me that I'm going to go around backwards, which means I'm going around clockwise, 210 degrees. So 210 degrees is going to land somewhere up here. 30. 210 is 30 past 180. And then we're going to close into the x-axis so that we're enclosing that reference angle to make our triangle. 30 is a special angle for us because that turns us into a 30, 60, 90 triangle. The sides of the 30, 90, the pattern needs to be memorized, so put it on a flashcard, do whatever it takes to get this pattern memorized. Across from the 30 is 1, hypotenuse is 2, across from the 60 is the square root of 3. Okay, 1, 2, square root of 3. Across from the 31, and across from the 60, the square root of 3. Because we are drawing triangles on an xy axis, that means that they have direction as well as length. So we may apply negatives to some of the sides in our triangles to denote direction. We're not thinking about a negative length because that doesn't really make sense, but a negative direction. So when we graph, we consider the left-hand side of our x-axis to be negative values. So this square root of 3 is on the left-hand side of that x-axis, so that square root of 3 needs to be a negative value. That negative denotes its direction, that it's on the left. As far as vertical goes, on our y-axis we consider up to be positive and down to be negative, so that 1 is in an upward direction, so that 1 is a positive value. Hypotenuse is always positive no matter what it looks like. We're ready to SOHCAHTOA. So what is SOHCAHTOA for tangent? Opposite over adjacent. So from that 30-degree angle, that inside reference angle is always the one that we're going to be focusing on. From the inside reference angle of 30, what is the opposite in this triangle? What's the opposite to the 30? The 1. And what's the adjacent to the 30? The negative square root of 3. And that'll be our answer. We learned earlier this year that it's considered to be somewhat inappropriate to leave square roots on the bottom of fractions, but when we do trig, we're just going to let it go. There's enough other stuff going on in this problem that we don't need to worry about fixing that as well. Next example. We're graphing in radians this time. What do I need to do when I graph in radians? Divide up the circle. How am I going to divide it up? Each half into 4 pieces. So 8 pieces total. Each half goes into the denominator number of pieces. So 4 pieces on the top, 4 pieces on the bottom. The numerator tells us how many pieces to count out. So if I have 8 in a circle and I'm going 11, that means I'm going to go around one whole time covers 8, and then 9, 10, 11 is 3 more pieces on the top. So that gives me my triangle. Always connect to the x-axis. Every time x-axis, you should always be drawing in the vertical segment of the triangle. How big is our reference angle? 45. 180 divided by 4 is 45. Your reference angle must always be, for these problems, 30, 60, or 45, because those are the angles that give us special triangles. The 45, 45, 90 triangle is 1 square root of 2 on the hypotenuse. One thing we need to consider that we may have some negatives for our sides here. What do you think about negatives in this? Negative 1 on the bottom. That horizontal line is on the left. Okay? So we think of left as being a negative direction, so that horizontal one left is negative. What about the vertical one? It's positive because it's up. It's going vertically up from the middle. Hypotenuse is always positive no matter what direction it looks like it's going. So now we're going to do SOHCAHTOA, except we're asked for cosecant, and cosecant isn't a part of our SOHCAHTOA. We learned about cosecant yesterday. What is cosecant the reciprocal of? Sine. What's SOHCAHTOA for sine? Opposite of hypotenuse. So if cosecant is the reciprocal, what would it be? Hypotenuse over opposite. So what's the hypotenuse in this triangle? Square root of 2. And what is opposite of that inside 45? The positive 1. So we can just make that a plain square root of 2 then. If you left it at square root of 2 over 1, I wouldn't mark you off. But if we can reduce it or simplify it down, we might as well do that. Questions? Next example. We begin by graphing. Start at the positive x-axis. Negative. So we're going to go around clockwise. Where will this land? In the lower left. How far before the 180? What's our reference angle? 30. Close in that reference angle. Always connect to the x-axis. Across from the 30 goes 1. Hypotenuse 2. Across from the 60 goes 43. Is negative. So both of those need to be negative. Hypotenuse is always positive no matter what direction it looks like it's going. So now we're ready to SOHCAHTOA. What's SOHCAHTOA for cosine? Adjacent over hypotenuse. What is adjacent to that reference angle? Negative square root of 3. And what's the hypotenuse? 2. And that's our answer. Questions? Okay, graphing away. 16 pieces. So that means I go around once, I cover 6. Twice, I cover 12. 13, 14, 15, 16. So I have to go around quite a bit. You do not need to draw the spiral if you don't want to. Okay? It doesn't really matter how many times we go around. In the end, all that matters is where that angle stops. So if you don't want to draw the spirals, you don't have to. But to get to 16, we have to do 6 all the way around once, 12 all the way around twice, and then 4 more sections. How big is our reference angle? Would be 1 across from the 60 is square root of 3 and hypotenuse 2. What do you think about negatives here? Both of those need to be negative. Hypotenuse is always positive, but we are horizontally to the left and vertically down. Now we're ready to SOHCAHTOA. We don't have a SOHCAHTOA for cotangent. What is cotangent the reciprocal of? Tangent. What is SOHCAHTOA for tangent? Opposite over adjacent, so we're going to do it upside down and do adjacent over opposite. What is adjacent to our reference angle? Negative 1. What is opposite of our reference angle? Negative square root of 3. Since we have a double negative, we can clean that up by making it positive, but we're going to leave our square roots on the bottom. Questions? Yes?
How do you find the negative? That doesn't make sense.
Negative, for the horizontal segment, we look at whether it's on the left or the right of center. So this is on the left of center, so left is negative. Right of center would be positive. For the vertical one, we're looking at is it on the top or the bottom. Bottom is negative, top is positive. Okay. I'll walk you through all of these. I want you to try 2 of them on your own. So for those, I want you to do secant of 5 pi over 6 and sine of 315. So go ahead and give those a shot. So for 5 pi over 6, how do I divide up my circle? 6 pieces per half. So I really only need to do the top half this time because that gives me enough to go 5 pieces. So if you don't want to divide up the whole thing, that's fine. Just make sure you divide up as much as you need. So I divide up half of 6 and I go over 5 of those. How big is my reference angle? 30. 180 divided by 6 is 30. And close it up with the x-axis to enclose that 30. 1, 2, square root of 3. What about negatives? Square root of 3 has to be negative. That will be hypotenuse over adjacent. What is the hypotenuse? Two is the hypotenuse. And what's the adjacent? Negative square root of 3. And we'll leave that square root on the bottom. 315, we'll begin by graphing. Where does it land? Lower right, and what's our reference angle? 45. Closing that reference angle with the x-axis. 1, 1 square root of 2. What about negatives here? Which one negative? The vertical one is negative because it's on the bottom half. The horizontal is the worksheet that's next in your packet. There are 16 questions. The first 4 are what we did yesterday using the unit circle. The next 12 are what we did today. That A, B, C, D there is just as a reminder of these are your steps. You don't need to give me specific answers for each part, but those are just the things that you need to think through in each question to get to your final answer.